He could not speak until he was 4 years old. His teachers called him slow. One told his father directly, "This boy will never amount to anything." He failed his first university entrance exam. He spent years working as a low-level patent clerk because no academic institution would hire him. And yet, in a single year, 1905, this same man published 4 scientific papers that permanently changed our understanding of space, time, energy, and light. He did not just advance science, he rewrote it from the ground up. This is the story of Albert Einstein, the most brilliant mind the modern world has ever produced, and one of the most misunderstood human beings who ever lived. On the 14th of March, 1879, in the small German city of Ulm, a boy was born to Hermann and Pauline Einstein. His father is warm and optimistic, perpetually enthusiastic about ideas that rarely make him money. His mother is sharper, more disciplined, and deeply passionate about music. She gave Albert a violin at age 6. He resists at first. Then something clicks. He plays for the rest of his life. But Albert is a puzzle to everyone around him. He does not speak until he is nearly 3 years old. When words finally come, he repeats every sentence quietly to himself before speaking it aloud. At school, he is outstanding in mathematics and physics, but despises the rigid, authoritarian teaching style of the German education system. He wants to ask why. His teachers want him to be quiet and comply. One tells his father plainly, "Your son will never amount to anything." 2 experiences in his childhood planted seeds that defined the rest of his life. The first is when his father brings home a compass. Albert is 5 years old. He stares at the needle, always pointing north, no matter how he turns it. The idea that invisible forces can act on physical objects without touching them fills him with a wonder he later describes as almost spiritual. He never loses that feeling. The second experience is a mathematics book. At 12, Albert works through every proof in a single summer, consumed by the elegance of a system where truth can be arrived at through pure logic alone. These 2 experiences tell us everything. He is not interested in memorizing what is already known. He wants to understand why things are the way they are at the deepest possible level. Einstein arrives in Switzerland at 16 with no diploma and no clear future. He sits the entrance exam for the Swiss Federal Polytechnic in Zurich and fails. He spends a year studying, sits the exam again, and this time passes. But his relationship with his professors remains difficult. He skips lectures he finds uninspiring, borrows notes from a classmate named Marcel Grossman, and spends his own time reading the cutting-edge physics papers of the day. He is self-directing his own education alongside the one the institution is trying to give him. When Einstein graduated in 1900, he fully expected an academic position. He is not offered one. Every professor he approaches turns him down. For 2 years, he drifts through temporary work and rejection. He later describes this as the most humiliating period of his life. Then, in 1902, Marcel Grossman used his father's connections to secure Albert a job at the Swiss Patent Office in Bern as a junior technical examiner. His academic peers would have seen it as a defeat. Einstein sees it differently. The work leaves his mind completely free. He has stability for the first time. And in the hours carved out from his patent duties, at his desk, in his lunch breaks, in the evenings at home, Albert Einstein begins to think. Without supervision, without politics, without anyone telling him which questions are worth asking, he is 26 years old, with no laboratory or academic title. He has a government desk in Bern and a mind that cannot stop asking questions about the nature of the universe. What happens next stuns the entire scientific world. In 1905, Einstein publishes 4 scientific papers that permanently altered humanity's understanding of the universe. Physicists still call it his miracle year. The first paper proves that light is made up of discrete packets of energy, what we now call photons. This insight forms one of the 2 pillars of quantum mechanics, the framework underpinning every piece of modern technology, from smartphones to MRI scanners. It is for this paper, not relativity, that Einstein eventually received the Nobel Prize. The second paper provides the first conclusive proof that atoms physically exist. In 1905, this was still seriously debated. The third paper introduces the special theory of relativity. Its central argument is almost impossibly bold. The speed of light is constant regardless of how fast the observer is moving. If that is true, then space and time cannot be the fixed constants Newton described. Time slows as you approach the speed of light. Space contracts. This is not a minor adjustment to existing physics. It is a demolition of the framework that science has operated within since Newton published his laws in 1687. The fourth paper is just 3 pages long and contains the most famous equation in human history: E equals mc squared. Mass and energy are 2 forms of the same thing, and even a tiny amount of mass contains an almost incomprehensible amount of locked energy. This equation is the theoretical foundation of nuclear power and our understanding of how stars burn. 4 papers, 1 year. One patent clerk in Bern with no equipment and no academic position. The world is beginning to notice. After 1905, Einstein's life changed slowly at first and then all at once. By 1914, he was in Berlin at the Prussian Academy of Sciences on a salary that required him to do nothing except think. But special relativity has a limitation. It says nothing about gravity. Einstein suspects that Newton's theory of gravity, which has worked for over 200 years, is fundamentally incomplete at the deepest level of reality. He spends 10 years on the problem through false start after false start. His marriage to Mileva collapses under the pressure. They separated in 1914. Through all of it, he keeps working. In November 1915, after a period of calculation he describes as the most exhausting intellectual effort of his life, Einstein published the general theory of relativity. It is the greatest scientific achievement of the 20th century. It proposes something that sounds almost like poetry, stated plainly. Gravity is not a force in the way Newton described it. It is a curvature of space and time itself. Mass bends the fabric of space-time, much like a heavy ball on a stretched rubber sheet creates a depression that draws nearby objects toward it. General relativity predicts that light should bend as it passes close to a massive object like the sun. On May 29, 1919, a total solar eclipse allowed British astronomer Arthur Eddington to test this prediction. He photographs stars near the edge of the eclipsed sun. The stars have shifted, exactly as Einstein predicted. On November 7, 1919, the results were announced in London. The Times runs the headline, "Revolution in Science. Newton's ideas were overthrown." Overnight, Albert Einstein became the most famous person on Earth. Fame on the scale. Einstein experienced after 1919 is strange and uncomfortable. He finds celebrity slightly absurd, but understands it is a resource. He becomes a prominent advocate for pacifism, a supporter of Zionism, and speaks publicly against racism during a visit to America in 1931. But in Germany, the mood is darkening. The Nazi Party targets Einstein specifically. He is Jewish, an internationalist, a pacifist, everything the Nazi ideology opposes. Nazi physicists attack what they call Jewish physics, claiming Einstein's theories are racial propaganda. When a book is published titled 100 Authors Against Einstein, he responds, "If I were wrong, one would have been enough." In January 1933, Hitler was appointed chancellor. Einstein is in America when the news arrives. He decides immediately. He will not go back. His bank accounts are seized. His apartment is raided. One Nazi publication runs his photograph under the caption, "Not yet hanged." Einstein settles in Princeton, New Jersey at the Institute for Advanced Study, becomes an American citizen in 1940, and never returns to Germany. But the equation he published in 1905 is about to force him to confront the most agonizing moral question of his life. By the late 1930s, physicists understood in precise detail what E equals mc squared means in practical terms. Nuclear fission, splitting an atom to release enormous energy, is now achievable. In 1938, German chemists successfully split the uranium atom in Berlin. The alarm among scientists in America, many of them European refugees who know the Nazi regime personally, is immediate. If Germany builds an atomic bomb first, the consequences are catastrophic. They need someone whose name cannot be ignored. In the summer of 1939, physicist Leo Szilard visited Einstein at his cottage on Long Island. Einstein listens, grasps the implications immediately, and agrees to sign a letter to President Roosevelt, warning that nuclear chain reactions could produce bombs of devastating power. The letter is dated August 2, 1939. Germany invades Poland 30 days later. The result is the Manhattan Project. Einstein himself is excluded. His political views cost him the required security clearance. The man whose equation makes the bomb theoretically possible is kept outside the door of the project that builds it. On August 6, 1945, a single bomb destroyed Hiroshima. Between 70,000 and 80,000 people die instantly. 3 days later, a second bomb destroyed Nagasaki. Einstein hears the news on the radio. His reaction is a single, quiet phrase. "Oh my." He spends his final decade campaigning relentlessly for nuclear disarmament, co-signing the Russell-Einstein Manifesto in 1955, warning world leaders that nuclear weapons pose a genuine threat to human survival. He once said, "I made one great mistake in my life when I signed that letter to President Roosevelt. It is the statement of a man who understands that even the right choice, made with the best available information, can have consequences no amount of genius could have fully foreseen." In Princeton, Einstein walks to the Institute every morning, plays violin in informal chamber groups, and sails on the lake badly and happily. But what he is thinking about is the problem that has consumed him since the 1920s, the problem he never solves. Quantum mechanics describes a universe at the subatomic level that is fundamentally probabilistic. Reality is not determined. It is a cloud of probabilities that collapses into a specific outcome only when observed. Einstein cannot accept this. He insists that God does not play dice with the universe. He spends the last 30 years of his life searching for a unified field theory, a single framework bringing together general relativity and quantum mechanics. a theory of everything. He does not find it. The theory remains unfinished on his desk at his death. It remains the deepest unsolved problem in physics today. In April 1955, Einstein developed an abdominal aortic aneurysm. Surgeons offer to operate. He refuses. He says it is tasteless to prolong life artificially. I have done my share. He asks for his notes and keeps working until he can no longer hold a pen. On April 18, 1955, Albert Einstein died in Princeton Hospital. He is 76 years old. His final words, spoken in German to a nurse who does not speak the language, are lost forever. The doctor who performs the autopsy removes his brain without authorization, convinced that somewhere inside that organ lies the physical explanation for the most extraordinary mind in modern history. It travels across America in a jar for decades. What they find is suggestive, but ultimately inconclusive. The explanation for Albert Einstein cannot be found in anatomy. Albert Einstein has been dead for over 70 years. His name remains the single most universally recognized synonym for human intelligence the world has ever produced. But reducing Einstein to a synonym for cleverness is the greatest disservice we can do to his actual legacy. What he represents is not just extraordinary intelligence. It is something rarer and more instructive. The courage to ask questions that everyone else has already decided are settled. His story teaches us that rejection does not have to define a person. It can be the very condition that sets a genuinely original mind free. It teaches us that imagination is more important than knowledge. His breakthroughs came not from a laboratory, but from thought experiments, from a young man sitting alone asking what the universe would look like if you could ride alongside a beam of light. The mathematics followed the imagination. It teaches us that perseverance through failure is not stubbornness, but conviction. And it teaches us that knowledge without moral responsibility is not wisdom. The scientist who unlocks a force and walks away from its consequences has not fulfilled their obligation to humanity. GPS systems require corrections based on general relativity. Without his equations, your navigation app would drift by several kilometers every day. Nuclear power, lasers, MRI scanners, our understanding of black holes, and the Big Bang. All of it traces to the framework Einstein built. In 2015, exactly 100 years after general relativity was published, scientists detected gravitational waves for the first time. Ripples in space-time produced by two black holes colliding over 1 billion light-years away, traveling across the universe for 1 billion years before reaching our detectors. Einstein predicted they would exist in 1916. He is still being proven right about things he calculated over a century ago. He was not a perfect man, a neglectful father, an inconsistent husband, capable of profound personal coldness. But he approached the universe with a sense of wonder that never diminished from the moment a 5-year-old boy held a compass and could not understand why the needle always pointed north. That wonder, sustained across a lifetime, disciplined into mathematics, aimed at the deepest questions the human mind can ask, is what Albert Einstein actually was. A man who looked at the universe with completely open eyes and changed what all of us can see.